This is question number 8. This is part A. First of all, question 8 says triangle PQR has vertices 2, minus 3, minus 3, minus 2, and 3, 0. Part A says find the equations of the perpendicular bisectors of sides RQ and PQ. So this is actually like two separate questions in part A. So we'll take them one at a time. So we'll find the perpendicular bisector of side RQ first of all. So I'm not going to draw the whole triangle out, I'm just going to draw side RQ. We're asked to find the perpendicular bisector. So perpendicular bisector first of all means that it's in the midpoint of that side. So that's we're bisecting it, so that means we're getting it in the middle, and it's also perpendicular, which means it meets this side at a right angle. So the line we're trying to find the equation of is represented by this green line here. We can see it's perpendicular, it meets at a right angle, and these two dashes indicate that we are in the middle, the midpoint. So to work out the equation of a line, we need a point and the gradient. So if we think about the gradient first of all, there's no way of directly working out the gradient of this green line because we only, in fact, we have no points at present on the green line. What we can do though is using the two endpoints R and Q, we can work out the gradient of this line, and then we can use our perpendicular lines gradient formula to work out the gradient of the green line. So first of all, we'll put down our gradient formula for the line RQ. So we're working with points R and Q. So we'll have y2 as 0, take away y1, which is minus 2, and on the bottom line, x2, which is 3, take away x1, which is minus 3. That gives us 0 minus minus 2, which is 0 plus 2. And on the bottom line, we have 3 minus minus 3, which is the same as 3 plus 3. So that gives us 0 plus 2 is 2 on the top, and 3 plus 3 is 6 on the bottom. So 2/6, which can be simplified to 1/3. So the gradient of the line RQ is 1/3. We mentioned our formula for the gradients of perpendicular lines earlier. So if M1 equals 1/3, then M2 is just this gradient inverted, turned upside down, with the sign changed. So M2 is 1/3 turned upside down, which is 3/1, which is just 3. And the sign is changed, so that was positive 1/3, which means our gradient is minus 3. So the gradient of our green line is minus 3. So that's the first thing we need to work out the equation of a green line. What we need now is a point, and that's going to be this point here, the red point at the end, and the red point is the midpoint of the line RQ. So we'll call our midpoint A, and writing down our midpoint formula. Our midpoint is going to be x1 plus x2 over 2, comma y1 plus y2 over 2. So remembering that we're working with points R and Q again, substituting in our values, we get x1 is minus 3, x2 is 3 over 2, and then y1 plus y2, so that's minus 2 plus 0 over 2. So minus 3, add 3 is 0, and 0 over 2, 0 divided by 2 is just 0. And on this line we have minus 2 add 0, which is just minus 2, and minus 2 divided by 2 is minus 1. So A, the midpoint of our line RQ, is the point 0, comma minus 1. So now we have a point on the green line, we have the gradient of the green line, so we can go ahead and work out the equation of the green line. So clear some space on this page, and keeping important information, the point and the gradient, we can write down the equation of a straight line formula, which is y minus b equals m bracket x minus a. So a is 0 and b is minus 1. So substituting into our equation, we have y minus 1 equals, gradient is minus 3 bracket x minus a, which is 0. Y minus 1, so two minus signs make a plus sign, so it's y plus 1 equals, multiplying this bracket out, minus 3 times x is minus 3x, and then minus 3 times 0, that leaves us with nothing here. So collecting everything to the one side, so we'll bring this minus 3x onto the left. Changing side means we change sign, which gives us 3x. We still have our plus y and our plus 1. That leaves nothing on the right hand side, so we have 0 here. And what we have now, 3x plus y plus 1 equals 0. That's the equation of the green line, our perpendicular bisector of line RQ.